Okay, we're going to go over the assignment number 2. And this is question number 4. First of all, it has to do with the elevator. Okay, here's what we have. We have an elevator. The mass is 1,700 kilograms. It tells us that it has a cable that can support a force, so we can call that the force of the cable, 25,000 newtons. It carries 10 people, and it says 50 kilograms each. So that's actually another mass, isn't it? That's 500 kilograms of people that are going to be in the elevator, and it wants to know what is the acceleration we can achieve. Okay, so let's draw a free body diagram. Let's draw our elevator. Now, the first mistake a lot of people make is they want to draw a normal force, because we've been doing a lot of questions with normal forces. But elevators are not on a floor or a surface, and so nothing pushes up in that sense. Instead, elevators are pushed upwards by the force of the cable. Sometimes we call this tension. Anytime there's a force in a rope, we call it tension. So if you see the word tension, that's just another name for a force in a rope or a cable or something. And you can use it in part of your net force equations, just like an F. A T is the same thing as an F. Okay. And that's 25,000 newtons, isn't it? Now, what else do we have? Well, there's going to be a force pulling down, a force of gravity. And we'll figure that one out after. And really, if you think about it, that's it. There's no friction, there's no sideways forces on an elevator. So the elevator force diagram is actually pretty simple. Okay. Now, what's the mass? Well, if we go back, we have two masses. We have 1,700 kilograms for the elevator, but also 500 for the people. So we'd have to add that together, right? So 2,200 kilograms is the mass of this elevator. So I'll squeeze that in here. 2,200 kilograms. Okay, let's draw our net force equation. Well, there's only an F net Y in this case. There's no X movement. And there are only two forces involved, the cable and the force of gravity. So I put them in. That's a C, by the way, for cable. Good. Now, remember what we do here. F net equals ma. That's Newton's second law. The force of the cable is 25,000 newtons. And we know that it's an upward force from the picture, so I'll use a positive number for that. Now the downward force, well, I'm just going to put in mg first of all before I start putting any numbers in there, because we don't really know yet what those numbers are going to be, right? Remember that rule, Fg equals mg. That was the formula from gravity. Okay, let's keep going. Now the m is our mass. Our total mass is 2,200. A equals 25,000. Now watch this. 2,200. Oh, I'm gonna go back there. I jumped the gun on that. Let's go back. Okay. 2,200 multiplied by 9.8. But when I look at my picture, it's a downward force of gravity right there. So that means I want to put a minus in there. And now you can see what happens here. If we just do some math, we should be able to crank out the A. So you'll notice the process. We just draw the free body diagram and draw the forces involved. Don't make the mistake of adding forces that aren't there, like putting in a normal force because you always did before. Remember, physics is not memorized solutions. It's figuring them out as you go, and each one is unique. Each one is a bit different. You have to use what you've learned and what you know to figure out what to do. You can't just memorize what to do. Okay, so let's go through this. Well, we have 2,200 times 9.8, which is going to make that a fairly big number, 21560. And we have all of this that we did nothing with yet. So there's what we have. So we're going to subtract that. We're going to subtract that from the 25,000. That's going to give us 200A equals 3440. And when we divide that both sides by 2200, we get an acceleration of 1.56-ish meters per second squared. So the beautiful thing is, once you figure out the picture that we drew here, and you draw the F-net or write the F-net equation, no matter what you're looking for in the question is going to pop out of this. Everything that could possibly be asked is in here. There's nothing else involved because it describes the whole situation. Okay, so that's the end of that one. And then I'll do another video to help you with number